This video will give examples on how to find limits. Our first function has x approaching 3, 10x plus 2 over x minus 8. Our first thing to try was to plug it in. So if we plug it in, then we have 10 times 3 plus 2 over 8 minus 3, or 32 over 5. So that's just our limit. Simple enough. Our next is x approaches 2, x squared minus 4 over x minus 2. In this case, if we try to plug it in, we end up with 2 squared minus 4 over 2 minus 2, or 0 over 0, which is bad. So we'll have to try to come up with something else. We can try our factoring method. We'll take x squared minus 4 over x minus 2, then factor it. And so now we can cancel out the x minus 2 terms. And we can equate the two limits. And so now that we have it in this form, all we have to do is plug it in. So 2 plus 2 equals 4, and we've found our limit. The limit as x approaches 4, 2 minus the square root of x over 4 minus x. We always want to try to plug it in first. So if we plug it in here, we get 2 minus the square root of 4 over 4 minus 4, or 0 minus 0, which, as we've said before, is bad. In this case, we can't factor either denominator or the numerator, so we can try multiplying by the conjugate. So we'll take this, multiply everything out, and so on the top we end up with 4 minus x, and on the bottom we have 4 minus x times 2 plus the square root of x. Now, from our factoring method, we know that we can cancel out the two terms, replace our limit expression with this new expression that we found, 1 over 2 plus the square root of x, and so now we can just plug in our value 4, and we end up with 1 over 2 plus the square root of 4, or 1 over 2 plus 2, 1 over 4. The limit as x approaches 11.3 of the function 3. In this case, our answer is simply 3, because really, if you imagine the graph of f of x, where f of x equals 3, this graph is just a constant at 3 the entire time, so no matter what x value you're approaching, you're always going to get the limit equaling 3. The limit as x approaches negative 5 of this chunk of stuff. So let's try to plug in negative 5. What we'll get is negative 125 plus 9 times 25 plus 20 times negative 5 over 25 plus 3 times negative 5 minus 10. And we end up with a 0 over 0. Bad. This means that we'll have to try something else. Let's try to factor this. If we factor it, what we end up with is we can take out an x, and that leaves us with x squared plus 9x plus 20 on top, and then we'll keep our denominator. Okay, now we can keep factoring. So this can turn into x plus 4 times x plus 5, and our bottom can turn into x plus 5 and x minus 2. So now we see that we can cancel out the x plus 5 terms. So in our limit, we can rewrite that as x approaches negative 5 with our function being x times x plus 4 over x minus 2. And at this point, we can just plug it in. So that would just equal negative 5 times negative 5 plus 4 over negative 5 minus 2, or negative 5 times negative 1 over negative 7, or negative 5/7.